class for our topic will be your enzyme, its mechanism, and the factor influencing your enzymatic action and your clinical enzymology. So first, our objective for this lesson is to describe the mechanism of action of your enzyme, identify and explain the factor that affects your enzyme activity, and describe the medical application of your enzyme. So first, the mode of enzyme action. So usually, again, we already mentioned from the previous lectures about enzyme that your enzyme usually acts as a lock-in key with its substrate. So meaning your enzyme only activates a specific substrate. So here is a depiction of your lock and key model. So first you have a substrate. Okay. Next is your enzyme. Okay, so this is the active site of your enzyme, and once that your substrate, okay, enter the specific area, okay, kaya lock and key model ito kasi po, as you can see, it has a specific shape that your substrate will bind to. Okay? So after that, no, after nyan, mapunta sa enzyme, it will bind and be activated. Okay, it is now known as your enzyme substrate complex. Then your enzyme will hasten, okay, or will fasten the chemical reaction, breaking down your substrate or combining them and producing different products. And your products will be leaving the active site of your enzyme, and again, your enzyme is not reduced or increased. Okay, so sa enzyme walang effect. Kay substrate lang nagkakaroon. So the surface of the substrate contacts with your specific region of the surface of your enzyme molecule. This is now called your active site. A temporary intermediate compound form is called your enzyme substrate complex. So yan na yung combination of your enzyme and your substrate. And the substrate is then transformed into your product. So again, your products can be combination of substrate or degradation of your substrate. Then the products are now released from your enzyme substrate complex, and the enzyme is again recovered and remained unchanged. So sabi nga natin ng mga previous lecture, hindi nagsisira or nababawasan yung enzyme natin. Only the products are transformed. Okay, the activation energy is the minimum amount of energy that is required to activate atoms or molecule to a condition in which they can undergo chemical transformation or physical transport. And your activation energy is usually required in order for your enzyme and substrate complex to be activated. So we have also theories explaining the mode of enzyme action. So what are these? So first is your Fisher's theory or the lock and key theory. So the enzyme and substrate, okay, complex theory. So the active site of the enzyme and substrate have complementary structure. So ito yung pinakita natin kanina. Hence, they fit together as a key fits a lock. So may specific enzyme for a specific substrate. Yun ang sinasabi ni Fisher. While they have bounded in the chemical or the enzyme substrate complex, catalytic reactions occur. So kung wala nito, enzyme substrate complex, hindi ka magkakaroon ng catalytic reaction because if you have only substrate, hindi ka magpo-form ng product. If you only have enzymes, hindi ka din magpo-form. So kailangan magkasama silang dalawa. The products of reaction leaves the surface of an enzyme and combines with another molecule of the substrate. So example, okay, nagproduce ka na ng product, it again can combine with another substrate and be again activated and produce another product by your enzyme. So example is E plus S is equivalent to ENS complex, and your ENS complex will produce product plus enzyme. Okay, so for example, sucrase plus sucrose will produce sucrase and sucrose complex. That's your enzyme substrate complex. Okay, this is your substrate. Okay? Sorry. This is your substrate and this is your enzyme kasi nga merong ACE. Tandaan natin yung mga enzyme natin ay may ACE. So, your sucrase-sucrose complex will produce, okay, glucose and fructose plus sucrose. Okay, ano yung mga yan? So, your sucrose is composed of your glucose and fructose. So, it could be degraded as to glucose and fructose and it could also still have a sucrose remaining. Okay? So, again, ulitin natin. Ulit. Again. So, for fissures, ang meron, si enzyme plus substrate will lead you to enzyme substrate complex. Then your enzyme substrate complex will produce products in your enzyme. Okay? Your enzyme. So sucrase, this is your enzyme, plus sucrose will yield sucrase and sucrose complex. This is your enzyme substrate complex. Then your sucrase sucrose complex will yield to glucose and fructose plus sucrase. This is a typographical error. This is sucrase. This is your enzyme. Okay, so your sucrose is now degraded with or to glucose and fructose. This is the monosaccharide form. This is disaccharide. Okay, so in depiction, okay, so si Lock-in-key hypothesis naman, okay, yung dalawang substrate or yung substrate mo will fit into specific shape of your enzyme in order for it to produce a product. Okay, so again, this is a typographical error. This should be sucrase. Next, we have your Koshland's induced fit theory. So in this model, the substrate still needs to fit, okay, the enzyme like the key, but instead of simply fitting into the keyhole, some types of modification is induced in the substrate, enzyme, or both. Okay, to modify, in the modification begins the process of your reaction. So at first, substrate binds as the specific part of your enzyme. They lead to more secondary binding and conformational changes. The substrate induces conformational changes in the enzyme such as precise orientation of your catalytic group is affected. So kay Koshland naman, no, para pa rin siyang kay Fishers. But, okay, your enzyme can modify itself or your substrate can modify itself in order for it to fit with your enzyme or substrate. Yun lang yun naman yung sinasabi niyang additional na modification process. Okay? So, pwedeng yung enzyme ang mag-iiba ng shape or si substrate in order for them to fit essentially. So, factors that influences your enzyme reaction. Okay. The concentration of your substrate. So, concentration of substrate is the first factor. So, increase in concentration of your substrate will increase the enzymatic reaction. Okay? Next, concentration of your enzyme. Increase of your enzyme, increase enzymatic action ulit. Temperature. Okay? The optimum temperature of enzyme in the body is 37 degrees. Again, higher than that could lead to coagulation of your enzymes, okay, and destroy them. So with each 10 degrees increase in temperature, usually it doubles or triples the reaction rate. For example, naging 47 degrees ito. So times 2 or times 3 yung bilis ng enzyme reaction. Rapid inactivation of your enzyme occurs at the temperature above the body temperature. That's why, no, in increased body temperature, in fever, okay, delikado yung fever natin kasi nga, okay, it could cause enzymatic reaction to speed up and again, coagulation of your proteins. And remember, your enzymes are made up of protein and it could be destroyed easily in higher temperature. So lower temperature naman, it slows down the action of your enzymes but do not destroy them unlike your higher temperature. So again, concentration of substrate, mas madami yung substrate, mas madaming enzyme reaction ang mangyayari. Mas mataas yung concentration ng enzyme, mas madaming enzyme, mas madami pa ring enzyme reaction na mangyayari. And sa temperature, the higher the temperature, the higher the rate of the reaction, mas mabilis yung reaction, at pag mababa naman, mas mabagal. Next factor is you have your pH. Okay, the acidity and the alkalinity of your substance. Okay, it has a specific optimum pH at which it exerts its maximum activity, and it loses its activity rapidly on either side of this optimum pH. So for example, your pepsin is optimally active at pH of 1.5 to 2.2, and this is the pH of your gastric acid. Okay, kaya in gastric environment, in the higher acidity, okay, the acidic area or the acidic nature, your pepsin will be activated. Your lactase is slightly acidic and your trypsin is slightly alkali. Okay, the presence of your accelerators, this is also a factor wherein it activates your enzymes such as metallic iron, such as your ferrous, ferric, cobalt, magnesium, manganese, and your molybdenum. Presence of your inhibitors, so those inhibitors that will slows down your enzyme reaction. It has the ability to combine with enzyme in a reversible or irreversible reaction. Okay, hence it blocks the enzyme catalysis. So for example, you have your antibiotics wherein sample are your streptomycin. So anong ginagawa ni streptomycin? It blocks the enzyme produced by your Streptococcus streptokinase. Okay? So walang lysis of your cells. We have also anti-enzymes, your antitrypsin from your soybean. Okay? Your anti-metabolites such as your sulfanilamide, other poisonous drugs such as your formaldehyde. This is also known as your formalin. Okay, it slows down the digestion process of your protein. Also your chloroform and your carbon tetrachloride or your CCl4. Cyanide, heavy metals such as silver and mercury. So yung mga yan, it inhibits enzyme release or enzyme activation. That's why in cyanide poisoning and your silver and mercury poisoning, usually they affects your blood and your bone marrow in decreasing the production of your blood cells. Next, environmental hazards. So again, the exposure to your mercury. Okay, mercury from phenyl mercuric acetate, okay, such as your fungicide. Okay, this is to prevent cellulose from rotting. So, pinaprevent natin yung growth of your fungi. Okay, methylic mercuric acetate, preventing rotting of your seed grains. So, yung mga ginagamit nating parang pesticides. Next is your cadmium. Okay, and this is another element derived from cigarette smoke. That's why usually those who have habits of smoking, okay, it affects their enzyme activity. Then your lead, this is usually present in gasoline and yellow painted pencil. Okay, so usually now we are having lead free pencils na. And your lead is because your lead is poisonous, okay, and can lead to lead poisoning, and that can affect also your blood production, especially your RBCs, okay, your inclusion bodies such as your basophilic stippling. We go now to clinical enzymology. So enzymes are commonly used in medicine such as analytical tool or reagent in measuring quantities of your various constituent in biological fluids such as your urease and your alcohol dehydrogenase. So ano yung mga gamit nito? These are your example of enzymes such as your urease, uricase, glucose, cholesterol oxidase, lipase, and your reverse transcriptase. So, saan sila ginagamit? So, urease in detecting your urea, especially this is used for alcohol testing. Uricase is usually for your uric acid test. Okay, glucose for your glucose oxidase. Okay, cholesterol oxidase is for your cholesterol, of course, measuring your cholesterols. And your lipase is for your triglyceride. This is both fats. And your reverse transcriptase, usually used for your PCR, your polymerase chain reaction, which will determine the DNA of your microorganism or even samples subjected to PCR testing. Next, as an index of pathological disease, some serum enzymes can be used as a marker for diseases such as alpha amylase in pancreatitis, which is normally elevated in a pancreatitis. Increase also in lipase usually could be indication that you have acute pancreatitis or even duodenal or peptic ulcer. Okay. Creatine phosphokinase or your CPK usually increases in the blood after a myocardial infarction. Other enzymes, you have your alkaline phosphatase, increase in rickets, okay, obstructive jaundice, and even in cirrhosis and cholecystitis. Acid phosphatase, okay, increase in carcinoma or cancer such as for your prostate cancer. Okay, lactate dehydrogenase or your LDH, increase in your viral hepatitis, this is hepatitis, heart attack, and even skeletal muscle diseases. Usually, your lactate is a subproduct of your muscle degradation. Aspartate transaminase or AST, increase in your myocardial infarction. ALT or your alanine transaminase, increase in liver diseases. That's why this is also within or usually used for your liver function test. And then your 5' nucleotidase, moderately increase in hepatitis and elevated in your biliary obstruction. So usually these enzymes are usually tested or requested in order to evaluate functionality of your organs such as your prostate, liver, okay, and even in your kidney. So that's all. Thank you.